Hello everyone, in today's video I'm explaining about Saytzeffs Rule or Zaitseff Rule. Okay, this rule is applicable in case of elimination reactions. Elimination is a process where two or more atoms are removed from a same molecule. Otherwise, we can say the saturated compounds are converting into unsaturated compounds through the elimination reactions. So let us see the Saytzeffs rule. According to this rule, when two alkenes are formed by the dehydration of alcohols or by dehydrohalogenation of alkyl halides. I think we have seen both the methods in the process of preparation methods of alkenes. Okay, so then alkene which is most substituted is considered as a major product. So for example, I am taking the butanol. Butanol, whenever we are doing dehydration of butanol, that means removal of water molecule, OH from here, H from here, if I remove, I will get the butene as a product. So butene and butene or but1ene, two products are forming here. So among them, but2ene is a stable product and major product. Okay, so here we can say this highly substituted alkene, that means double bond is attached to many more alkyl groups, but here double bond is attached to single alkyl group. So it is most substituted alkene which is a most stable and considered as a major product. And let us see the reason behind this. Now let us see the mechanism of dehydration of alcohols to understand more about this Saytzeffs rule. Okay, so dehydration of alcohol is taking place in the presence of sulfuric acid. So this sulfuric acid can dissociate into H plus and HSO4 minus. So for example, firstly I am taking butanol. So this butanol is having a lone pair of electrons on oxygen. So this oxygen lone pair of electrons attracting this proton from sulfuric acid. So now you are getting OH2 here. It is attracting and forming OH2, and because oxygen is donating electrons, it is getting a positive charge on oxygen. So in order to nullify this positive charge, next I am shifting this bonded electrons towards oxygen. So I am removing the water molecule out. Now you can see here this carbon gets the positive charge. So now we got an intermediate called carbocation. This is a primary carbocation. This primary carbocation can undergo rearrangement to form a secondary carbocation. This primary carbocation, see here, it is having a positive charge on first carbon. So next what I will do? Next I am shifting this bonded electrons towards hydrogen. Hydrogen gets negative charge. This negatively charged hydrogen is forming a bond with this positively charged carbon and forming CH3. And now this carbon is losing electrons, so it is getting a positive charge here. So it is a secondary carbocation. So now what I will do next? Let us see the formation from this carbocation. There is a formation of butane. Let us see that. So I am taking first primary carbocation. From this primary carbocation, this HSO4 minus attracting the proton. Okay, so this HSO4 minus attracting the proton. So I am shifting the bond towards up. So bonded electrons are shifting towards carbon. Carbon gets negative. This negatively charged carbon and this positively charged carbon forming a double bond, pi bond. Okay, so now you can see this proton is attracted by this HSO4 minus and coming out as H2SO4. Okay, so but1ene is forming as a product from primary carbocation. Now let us see secondary carbocation. Secondary carbocation I am taking again. To this secondary carbocation I am adding again HSO4 minus. This HSO4 minus attracting proton from this. So here I am shifting the bond up direction. This carbon is getting negative charge, this positive and this negative forming a new pi bond, that is a double bond. So this HSO4 minus is attracting the proton and coming out as H2SO4. This is a formation of but2ene from secondary carbocation. Okay, so now why we consider this as a major product when compared to this but1ene? Here if you observe, when compared to primary carbocation, secondary carbocation is more stable because of inductive effect. So here CH3 groups are electron donating groups. Here this positive charge is nullified by this two sides. Two sides you can observe electron donating groups. So positive charge is nullifying by two methyl groups, or one methyl group and one ethyl group. Here if you observe in case of primary carbocation, this positive charge is nullified by one alkyl group, that is propyl group. Okay, so here the positive charge is having less effect, less donating effect of this alkyl group, but here the positive charge is getting nullified by more alkyl groups. Because of that reason, the secondary carbocation is more stable when compared to the primary carbocation. So product forming by the secondary carbocation is more stable, that is butene, and it is forming as a major product. That is the reason in Saytzeffs rule we consider highly substituted alkene as a major product, because it is forming from most substituted carbocation. Okay, this is about Saytzeffs rule and its mechanism. Thank you so much for watching.